Okay, this, so they give us the information that the probability of successful rotator cuff surgery is 0.9. And it's interesting that they give us these probabilities because this is actually, we're going to see this kind of stuff again in chapter 4. These are called binomial probabilities because there's only two outcomes. The surgery is either successful or unsuccessful. So anytime there's only two outcomes, it's called a binomial probability. But anyway, that's coming up in chapter 4. So we've got two outcomes here. The probability of success is 0.9. That should be calculated then that the probability of failure, remember what the sum of all the outcomes is? You remember? All probabilities have to add up to be what? 1. So if the probability of success is 0.9, then the probability of failure is 0.1. These two have to add together to be 1. Of course, you could say if the probability of success is equal to 0.9, then the probability of failure is equal to 1 minus 0.9. So that's how we calculated it. It came out to be 0.1. Okay, so find the probability that 3 rotator cuff surgeries are successful. This is just like the fish. This is just like flipping a coin. It doesn't matter that we're going to do 3 of them. If we're going to do them all 3 in a row, it doesn't matter. The outcome of one surgery has nothing whatsoever to do with the outcome of the second surgery and the outcome of the third surgery. So we're going to be finding the probability of success and success and success. It doesn't matter that it's 2. We're going to follow the same rule. So we're going to do the probability of success times the probability of success times the probability of success. And remember, the reason that we do that is because these are independent events. One doesn't have any bearing on the outcome of the other. So this is 0.9 times 0.9 times 0.9. And those 3 things multiplied together is 0.729. Find the probability that none of the rotator surgeries are successful. So again, we're doing 3 of them right here. So we're doing the probability of failure times the probability of failure times the probability of failure. And we're finding the probability of failure and failure and failure. Probability of each one of those is 0.1 times 0.1 times 0.1, and that's equal to 0.001. Okay, this one, at least 1. Okay, now you can continue to do it using the same process that we've been doing here. At least 1. So what does at least 1? The probability of failure, we've only had one, so at least 1. Oh, this one says at least 1 is successful. So we could have the probability of failure, and the probability of success. That is at least 1. But it could be which one, or it could be that there's 2 successes. That's at least 1 success, right? So we've got lots of outcomes right here, and if we have to do all of these, then we're going to have a whole bunch of multiplying to do. So this is not the approach we want to take. Here's the approach we want to take. We want to take this approach: at least 1, and you might just want to memorize this. At least 1 is the complement. And do you remember what we learned about complements last time? At least 1 is the complement of none. Okay? Now remember, complements are found by saying 1 minus. So up here, We had success and failure. Those are complements of each other. So if we knew the probability of success, we were able to find the probability of failure by saying 1 minus. Okay, so this is the same thing. At least one is the complement of none. Well, that's what we did right here. We've already found the probability of one. So mathematically, we say if we find out 1 minus the probability of none, that equals at least 1. Okay, those are the same thing. So 1 minus 0.001, that's the answer that we got right here, is equal to 0.999. Okay, and the way that we write the probability of at least one, we're talking about an x value or an outcome. We could use an x value that's greater than or equal to 1. Or if you don't want to use x, you could say the success probability that success is greater than or equal to 1. So that's what at least one looks like. So we would say that's equal to 0.999. All right. These problems down here are very similar to those. So you should try to work those out. And I believe I have a copy of these notes that I'll post, and it'll have these answers on there. But you should try to work those yourself. I am going to tell you before you get to do this by yourself that we need to know, what does unusual mean. So if your probability comes out to be less than 0.05, 5%, then it's considered unusual. Anything bigger than 5%, anything bigger than that is not unusual. Okay, so that is the guidelines that you get. So if you find the probability, so let's say the probability of getting none, this right here is very unusual, because this is smaller than 5% or 0.05. So this is unusual. This one right here, not unusual. All right. So again, you can look for my classroom notes. I'll post those so that you can go back and check to see if these are right or not after you try them.